The EERC is an absolutely fantastic place to work. Every one of my colleagues that got up here and talked before, it was an idea in an office, then an idea on paper, then an idea put out for funding, then all the work to get the funding, then the work to work with the partners, and then something turns into a piece of hardware, and then it's out in the field. We do that here day in and day out, and it's just an incredibly exciting place to be, so very honored to be here. Okay, here we go. All right, there we go. Okay. This is a map of the United States and all our contiguous properties in the U.S., the different regions of oil production in the nation and gas production. The numbers on the left are barrel oil equivalent per day. The percentages are showing you the percentage today that's being produced from each region. In terms of methane and what is occurring in the U.S. With scrutiny on methane, when I look at this map, I see a small geographic target out there, but an incredibly important infrastructure base and resource base in the United States that's critical to our economy and our national security. We have nearly 1 million wells in the U.S. that are active. It accounts for 8% of the U.S. GDP. When you compare that to other sectors, healthcare is the highest at 18%, manufacturing at 10.8%, which includes the tech sector. Oil and gas not just rivals all this, but it underpins all this activity in U.S. economy. And if you just want to throw out a funny number, the national debt's at $34 trillion. So I've been learning to use AI, and so I asked AI, what is the U.S. government saying about methane emissions in the oil and gas industry? And the present administration has taken a strong stance against methane emissions. What's that precipitated recently? In December 23, EPA's methane rule was finalized. It's stricter leak detection repair, limitations on routine flaring, reduced emissions from storage tanks. There's a punitive penalty associated with this, and we're going to see potentially effective date of provisions coming this year in September 2024. More provisions going in effect later over time. The states have 2 years to figure out how they're going to handle this new methane rule. 1 year for EPA review, 18 months. Anyway, you get the picture. We have some time to react, but this is our present landscape today. The fight's been ongoing, so our delegation has spoke out against the rule, and we've been fighting this battle in particular in the courts since 2016. So what happens down the road here, where the fight lands, all those kinds of things, each one of you are out there trying to prepare for this, trying to understand what it means to your operations and how do we do things. Well, in the engineers world, what we can control is innovation and working on technology and staying ahead of it. So, what the EERC sees is that, let's meet methane objectives with innovation and technology. What we do here, what we work on every day is to develop new technology, test ideas, and collaborate with our partners. And yeah, I'm asking you to get involved. Bakken Production Optimization Program, iPIPE, various demonstration projects, and then pursuing funding. So also, this last month, DOE and EPA have announced that they're going to spend $1 billion out of the Inflation Reduction Act towards reducing methane emissions. Some of that I think we can definitely use to be innovative and bring new technologies to bear that are economic. So capturing methane to make money. One of those things that we're working on is something we call polar bear. And we've named it because of the robustness and adaptability of that animal. I'm showing some data on the screen. What I'm showing is characterization of flaring in North Dakota. We're doing a great job. We're down to 5% flaring, but the goal is to get to zero. How do we go after that piece of flaring that's no longer the low-hanging fruit? That's the more difficult gas to go after. That gas is not stranded. Most of it is being flared from wells that are connected to a pipeline in some form or another. And what I'm showing with the bar graph is a representation of percentage flaring. So wells that flare most of their gas are on one side of the curve, but wells that flare less than 10% of their gas make up a large majority of flared volume. And so if you imagine a well pad and it's only flaring 10% of the time, the economics to capture that gas are incredibly difficult. So what I'm saying is conventional VRUs are very expensive relative to that metric, and so new technology is needed. That's what we're doing here. The picture of the hardware is just showing one example of a very simple machine. That machine compresses gas to 250 psi and cools it to make liquid in a little tiny box. Those are the kind of concepts that we're working on to bring that new technology to bear so that we can monetize that gas. iPIPE is another program we're working in. We work with a lot of different technologies around leak detection. I won't go into all of them. You can read them on the screen. But I will say this, that in the iPIPE program, when I talk about working ahead of the federal government, we are now finding leaks before the landowner finds them. And the holy grail is to find leaks that you can't see. So you can't see them in your SCADA data. You might not be able to even see them from an airplane or even with a kind of a drive-by inspection. But we're able to find these, go out and inspect them, and then get down to addressing pinhole leaks. And that's just starting to happen right now. It's been an investment in iPIPE over time, not just to work on technology, but to address the barriers within our organizations in adopting new technology early. And that's an example of about 6 years of working that through, internal within the company to finally be able to realize the benefits of it. So that's what I have to share with you today. We do this and more, and I'm happy to talk with anybody afterwards. I'll just mention on the tour that you'll be on tomorrow, there is a polar bear unit out there that we're testing. You're welcome to look at it. Thank you.